Computer generations. Each generation of computers is characterized by major technological developments that fundamentally change the way computers operate. This results in increasing smaller, cheaper, and more powerful and more efficient and reliable devices. The first generation of computers, spanning between 1940 and 1956, the first computers used vacuum tubes for their circuitry and magnetic drums for memory, and were often enormous, taking up entire rooms. They were very expensive to operate. They used a great deal of electricity, generated a lot of heat, which was often the cause of malfunction. First generation computers relied on machine language to perform their operations, and they could only solve one problem at a time. The second generation of computers, spanning between 1956 and 1963, that used transistor technology. Transistors replaced vacuum tubes and ushered in the second generation computers. A transistor is a device composed of semiconductor material that amplifies a signal. They were smaller, faster, cheaper, more energy efficient, and more reliable than their first generation predecessors. Second generation computers still relied on punched cards for input and printouts for output. The second generation computers moved from cryptic binary machine language to symbolic or assembly language, which allowed programmers to specify instructions in words. These were also the first computers that stored the instructions in their memory, which moved from a magnetic drum to a magnetic core technology. The third generation of computers, spanning between 1964 and 1971, inculcated integrated circuits. The development of integrated circuits was a hallmark of the third generation of computers. Transistors were miniaturized, that is, made smaller, and placed on silicon chips called semiconductors, which drastically increased the speed and efficiency of the computers. Instead of punch cards and printouts, users interacted with the third generation computers through keyboards and monitors and interfaced with an operating system, which allowed the device to run many different applications at a time, with a central program that monitored the memory. They were characterized by high reliability, smaller size, used parallel processing, and the introduction of simpler programming language, e.g. BASIC. The fourth generation of computers, spanning 1971, inculcated or introduced microprocessors in their technology. The microprocessors brought the fourth generation of computers, as thousands of integrated circuits were built onto a single silicon chip. Three basic characteristics differentiate microprocessors. Instruction set. This is a set of instructions that the microprocessor can be able to execute. Bandwidth. This is the number of bits processed in a single instruction. Then there is a clock speed given in megahertz. The clock speed determines how many instructions per second the processor can be able to execute. As these smaller computers became more powerful, they could be linked together to form networks, which eventually led to the development of the internet. The fourth generation computers also saw the development of GUIs, or graphic user interfaces, the mouse, and handheld devices. It also brought in the introduction of a wide variety of software. The computers also became cheap enough for schools and homes to be able to purchase. The fifth generation computers. These include the present computers and the future computers that will be able to integrate artificial intelligence in their workings. Fifth generation computing devices are based on artificial intelligence and are still in development, though there are some applications such as voice recognition that are being used today. Artificial intelligence is a branch of computer science concerned with making computers behave like humans. This includes playing games. Here, computers are programmed to play games such as chess and checkers. Expert systems, programming computers to make decisions in real-life situations. For example, some expert systems help doctors diagnose diseases based on symptoms. Natural language. This involves programming computers to understand natural human languages. And then neural networks, systems that simulate intelligence by attempting to reproduce the types of physical connections that occur in animal brains. And robotics, programming computers to see and hear and react to other sensory stimuli.